Hello everyone. In this session, let us discuss about region-based convolution neural network, basically RCNN, right? So in this session, let us discuss about region-based convolution neural network, basically which is called as RCNN. So we have a very good idea that how to do the object detection task, right? So how do we do that? Say, for example, we have an image. It will be using the object detection algorithm. We will be able to detect whether it is a car or a truck, or is it a van, or is it a lamp, right? So how a deep learning approach is basically used, right? So we have seen this multiple times, but still let us have a recap of it. So we will be having an input, and then we have convolution 1, and then we will be having pooling 1, and then we will be having convolution 2, pool 2, and then we may be having some hidden layers, and then there could be output, right? So this is how generally the convolution neural network looks like, right? So what do we do over here? We pass an image to the network, and then it is sent through various convolutions and to the pooling layers, right? So finally what we get? We get the output in the form of the object class, right? So for each input image, we get a corresponding class as the output, right? So what is happening here? First, we take an image as the input, then we divide the image into different regions, right? Then it is being divided into different regions, and then what will happen? Each region will be considered as a separate image now, right? Each will be considered as a separate image now. Now all the regions will be passed to the CNN to classify it into the various classes, right? So once we have divided each region into the class, then what we will do? We will combine all the regions to get the original image with the detected classes. So what is the problem with this approach, right? So here we can see that each region or each object may have a different aspect ratios and different spatial locations, right? So in some cases, the object may be covering most of the images, and in some cases, it may be covering a small percentage, right? So the shapes of the objects may also be different, right? So if you look at the car, that could be different. Lamp, it could be different, right? So because of these factors, we require a large number of regions, which is resulting in a huge amount of computational time. So this may be a big problem to us. To solve that, basically, we have come up with several other neural networks, right? So what are we trying to do over here? Instead of working on different regions, because here, what did I say? Like there will be input, and then it is taken into different region, and this will be used for finding out the classes, right? So instead of working on different regions, this RCNN algorithms, what it does is it makes a bunch of boxes. Okay, so it basically makes a bunch of boxes, right? And it checks whether these boxes contain that particular object or not. So it will identify whether the object is there or not. So we call these boxes as origin, right? So if you have to understand this, first of all, we should know what the selective search is, right? So how it can identify the different regions. So basically, here you have to understand 4 things. Okay, so one could be about the varying scales, it could be about varying colors, it could be varying textures, it could be about enclosure, right? It could be about enclosure. So what the selective search does, it will try to identify these patterns in the image, and based upon that, it proposes various regions, right? So let us see how the selective research basically works. Okay, so the first step is that the input is being taken. Okay, and then it will do the sub-segmentations, right? Then what will happen? Then combine those similar regions into a larger region. How the comparison will be done? So I have told about 4 things, right? So it could be based upon the color similarity. It could be color similarity, texture similarity, size similarity, or shape compatibility. Based upon that, all the regions will be combined. And finally, what will happen? These regions will then combined, and then the final object locations will be found. That is basically the region of interest. So what is happening over here? The input image is taken, and from that sub segmentation is being done, and then based upon the similarity they are being combined, and finally those regions will produce the so based upon similarity the combination happens, and finally these regions can produce the final output, right? So final object locations, right? So this is what happening over here with this RCNN, right? So how do we do this, right? So the first step what we do is we may be taking a pre-trained CNN, right? Pre-trained CNN is taken, right? We know about the CNN architectures and all, right? So the first step is that pre-trained CNN is taken, and then this will be, try to understand, pre-trained is taken, and then this will be retrained, okay? So then this model has to be retrained. Actually, most of the times, which one we try to train is the last layer of the network. Why do we focus on the last layer of the network? Maybe the pre-trained network may have 1,000 classes. Say if it is image.It, then it can have 1,000 classes. But basically, say for example, we are trying to make a model to identify the 10 digits. It could be youngest data. So there could be only 1,000 data. There could be only 10 data, right? So based upon the required number of output, we will be doing this, right? So here, what are we doing? We are retraining this model. We train the last layer of the network based upon the number of classes. What is the next step? Next step is the region of interest. That means what? ROI, right? So then we have to reshape so it can match with the input size, right? And getting this, we train support vector machine classifier to classify the objects and the background. So we train support vector machine, right? So finally, we can train a linear regression model to generate the tighter bounding boxes for each identified object in the image, right? So I hope it is clear. So first, we are choosing a pre-trained model. We are retraining the last layer of the model. We are identifying the region of interest. Then we are going ahead with the SVM to classify the objects. Then finally, we are making a linear regression model to find the bounding boxes for each identified object, right? Clear with that? Right. So, okay, so this is what we have to understand over here. So here the summary is that the image is taken, then region of interest is identified using some proposal method, and then what are we doing? So the first input is taken, and then ROI is being done by using proposal method. So here, which method we were discussing? Selective search method, and then we are reshaping it to according to the input of the CNN. And now this CNN will be used to extract the features, right? This is basically used for feature extraction, and using SVM support vector machine, we are trying to divide it into different classes. And finally, we are making the bounding box regression. Okay, this looks super cool, right? But are there any problems with this RCNN? Yes, the RCNN can be helpful for, basically, this is being helpful for object detection. Okay, so this is helpful for object detection. But this technique also has its own limitations, right? So, and also the most important limitation is that this is basically expensive. Right? This is basically an expensive matter, right? So here we are trying to extract 2000 images for each image based upon the selective search, right? So what are we trying to do over here? We are extracting features using this CNN for every image. Just imagine, like I said, as I told you, this is 2000, right? So for every image, how many we will be trying to do? N into, N in the sense, say I have N images. So the number of images into this number of regions. So number of images is basically N over here. The number of regions is 2000 over here. So 2000 into N. So this process has three models as we discussed in the previous slide. CNN for feature extraction, linear SVM classifier, regression model for tightening the bounding boxes, right? So now here the problem is, when you do all these steps, when you do all these processes, this may make the RCNN very slow. So for each prediction, it will take around 40 to 50 seconds. So what may happen is, it is very difficult when you try to handle a very big data set, very huge or gigantic data set. So there comes the another another method which is called as fast RCNN, right? So what was the problem with the RCNN? What we encountered the problem, actually the time was too much, right? It was taking more time, right? So how to reduce the time taken by the RCNN algorithm? So here what we already found, if there are a n number of images, it will be finding 2000 regions, right? So this is what we have discussed. So instead of running CNN 2000 times per image, we can run it just once per image and we can get all the region of interest, right? So that is why the author actually Girshik, okay? So his name is ROSS. So Rosh Girshik, okay? So he is the author of RCNN. He came up with some idea saying that CNN just one, instead of just once per image, then finding a way to share that computation across the 2000 regions. So in the fast RCNN, what we try to do is, we input the image to CNN, then it will generate feature map. Okay, from image, it will get converted into feature map. Now using these maps, regions of proposals are being extracted, right? Then we were using the ROI pooling layer to reshape. So which pooling layer we were using? ROI, okay, region of interest. Pooling layer is being used to reshape all the proposed regions into a fixed shape. Okay, so then it is being fed into fully connected network. So what happened over here? So the first step is about the image. Then it is being converted into a feature map, and then based upon this, ROI is being extracted, and then using the pooling layer, what happened actually? Reshaping is being done, right? And then it is being passed into fully connected network. Okay, so this is what basically happened over here, right? So now here, similar to the last case, here also we are taking the image as the input. So as I told you, like it is being passed to convolutional neural network. Okay, so ConvNet, which in turn generates, so this is being passed to ConvNet and it generate ROI, right? Now what is happening? A pooling layer is applied. Once you apply the pooling layer, we all know that what will happen when you apply pooling, reshape will happen according to the requirement of this ConvNet, and then it is fed into the fully connected network. Now what we will be connecting at the output? We all know that softmax, right? So softmax we will be connecting. So how many outputs should be there? That depends upon the number of classes of the data set that we are using. And along with that, we will also use linear regression so that we can get the bounding box coordinates, right? So instead of using instead of using the three different models like RCNN, fast RCNN, we can use a single model that can extract all the features from the regions and dividing it into different classes, and it can return the boundary boxes for the identified classes, right? So now we have taken an image as the input, then it is being passed to ConvNet, and then it is being fed into the pooling layer, and then finally it is put into the fully connected network as well as the bounding boxes using softmax and linear regression layer. So this is the summary of it, right? So now the here what we can see is fast RCNN actually solved two issues that we encountered in RCNN. That is basically one thing what we have seen is about this 2000, right? So passing 1 instead of 2000 regions per image to the coordinate, and using 1 instead of 3 different models for extracting features, classification, and generating bounding boxes. So those two major issues are being solved with the help of this fast RCNN. But definitely it also has its own limitations. The limitations are like it uses selective search only as a proposal method to find a region of interest. So again, we had the same problem of a slow and time consuming process, not like RCNN, but though it is better. But again, here we had the same issues, right? So it was taking 2 seconds per image to detect the objects, right? And which is actually comparatively better than RCNN, but still we are not really happy with this, right? So there was another one that is basically faster RCNN, right? So here, this is actually the modified version of fast RCNN. Here, what difference we can see is, like, instead of this also uses a selective search. Actually, fast RCNN uses selective search for ROI generation, right? But this one generates RPN. What is meant by RPN? Region Proposal Network. Okay. So what it does is, it takes image feature maps as the input and it generates object proposal. Okay. And it generates object proposal, right? So again, this is taking feature map as the input, and also it generates the object proposal. Okay. So here, let us try to understand this step by step so that it could be understandable. So what is happening over here? The image is taken as the input and then it is being passed to convolutional net, like the other case. Now here, what is being applied? RPN is being applied on the feature map. So what do we get as the output of this one? Object proposal. Then we will be applying the pooling layer so that everything will be of the same size. Okay. And then finally, the proposals will be passed to the fully connected layer. We all know that it has softmax as well as the linear regression layer to classify and output the bounding boxes, right? So this is what you have to understand about this, right? So here you can see this is the image over here. Then there is convolution layer, then RPN, and then here proposals, and then classifier, ROI pooling. Okay, so faster RCNN takes the feature maps from CNN and it is passing it to the region proposal network. So this region proposal network, what it does, actually it uses a sliding window basically over the feature maps, and at each window it can generate some anchor boxes, right? So this is what you can see. It can generate each one. So you can see the sliding window over here. Each one is generating K anchor boxes, right? So K anchor boxes. Look at the size and shape of the anchor boxes. You could see that it is actually different, right? So anchor boxes are actually fixed sized boundary boxes that are being placed throughout the image. But you can see that there are different shapes and sizes, right? So what happens in this anchor boxes, actually, it will be predicting two things. The first thing is about the probability. So the first is the probability that the anchor is an object. So this is being predicted by RPN, right? So RPN is predicting two things over here. The first is the probability that an anchor is an object. It does not consider which class the object belongs to, but it will try to find out whether it is an object. The second one is about the bounding box regressor, right? So for adjusting the anchors to better fit the object. So now we will be having different shapes and sizes of the bounding boxes which are then passed to the ROI pooling layer, right? Now, after this, what will happen? There will be proposals. The proposals do not have any classes actually. Now, what we will do, we will be taking the proposal and crop it so that each proposal has an object, right? So this is how the proposal layer basically works. Then these feature maps will be passed to the fully connected layer. Then we know fully connected layer has both softmax as well as the linear regression layer, right? Now let us try to understand, okay, are we happy with the faster RCNN, right? So as usual, all the object detection algorithm are trying to identify the object. Actually, what is happening here? The network does not look at the complete image of the image in one go, but what it is doing, it is focusing on part of the image sequentially, right? So here there will be some complications, like the algorithm requires many passes through a single image to extract all the objects. That is what I said, right? So when you take a single image, it is taking different region, and this is how it is being working. And since there are different systems working one after the another, the performance also further depends upon the performance of the previous system, basically, right? So this is what we should know. And also here, what we can say is the limitations. The CNN divides the images into multiple regions, right? CNN basically divides the image into multiple region, right? Into regions, right? And each region into various classes, right? So it needs lot of regions to predict accurately, and high computation time is being required, right? So this uses selective search to generate regions. So what we have seen is it is extracting around 2000 regions, right, per image. So 40 to 50 seconds it is taking for each region. Then it has to be passed to CNN. Then you has to use 3 different models for making predictions. You got my point. So fast RCNN, each image is passed only once to the CNN, and the feature maps are extracted. So here also selective search is used on the maps to generate the predictions, right? So again, here the combines all the 3 models, the same thing, right? So the selective search is low, computation time is high, right? So the one good thing about faster RCN is it is replacing the selective search method with RPN, which is making it much faster, 0.2 seconds. But object proposal takes time, and there are different systems working one after the other. So the performance of the system depends on how the previous system has performed, right? So hope this is clear to you about RCNN. We have discussed what is RCNN, what is fast RCNN, what is faster RCNN, right? And also we have discussed about the limitations in RCNN, fast RCNN and faster RCNN, right? So hope this is clear to you. So in this session, we had discussed about RCNN, fast RCNN, faster RCNN, right? So hope this is clear to you. Let us make it very clear, because this you should have a sound understanding about it, because you can expect a lot of questions related to this in the interview, right? So hope it is clear to you. Thank you.